Hello, welcome to the second half of week 3 lecture. The first half we looked at JUnit and how we can write some simple test cases. In this part, we will use something like a simple project just to discuss different aspects of a project, such as user stories, CRC cards, which we kind of alluded to last week, whereby you can decide how uh, the responsibilities can be shared by multiple classes and how the different classes can collaborate together to get the job done. And also, we will look at some important aspects or the main aspects of different UML diagrams. Although you will be looking at this in detail later, when you do a project, you often realize you need to look ahead and sort of have the big picture. And that's what we are trying to do in this lecture, or the second half of this week 3 lecture. So if with Java also, we will briefly look at the kind of classes and methods that can be of use to you when you start to develop medium to large scale projects. So you find out when you go out, very few people simply use a standard array. They use classes such as array lists, hash map sets, and so on, which simplify the task and helps you to model things using an appropriate structure. JUnit basically allows you to write test cases, as we saw last week, and we will see we should write both positive and negative tests. Positive means, if, for example, if you borrow a book, the status should change from being available to on loan. Negative testing means if the book is already on loan and you try to borrow a book, it's expected to fail, typically by throwing an exception, like borrow exception, for example. So initial user stories, as you probably would have started thinking about for your own project. In the case of a library system, a librarian may say, I should be allowed to add a book. I should be allowed to add a member. You notice that you can also think of conditions of satisfaction. This basically becomes, in a way, an acceptance criteria. So there could be multiple conditions of satisfaction attached to each user story. In this case, the librarian wants to make sure that you don't end up adding two books with the same ID, and similarly two members with the same ID. The system should automatically check that. Um, and as a librarian may also want to ensure only books that are available can be borrowed. In other words, the books which are on loan or on hold should not be borrowed. I want to ensure that um, only books on loan can be written, right? So as a member, uh, um, let's say a student, for example, or a staff, I can borrow up to the maximum specified number of books. In this case, we just set it to 2, just to make it easy for testing purpose. So it says here, ensure I cannot borrow more than 2 books. If you try to borrow more than the maximum number of books allowed, your method should check and throw an exception. Similarly, ensure non-members cannot borrow books. For example, a person who is not a part of that system, is not registered as a member, should not be allowed to borrow a book. Ensure number of books on loan is immediately updated. That means if you had 2 books and you borrowed another book, when that happened, the number of books on loan should be increased by 1. Right. So as we saw last week, one useful technique when you are thinking of classes and how they should interact, how the responsibility should be divided, is the CRC cards. Here there's an example given at the site for a library system. As you can see, there is a library class, a librarian class, a borrower, date, lendable. Um, book is a lendable, so it's kind of a subclass of a lendable, if you like. And as you can see, the responsibilities on the left hand side, and what other classes they collaborate to carry out this responsibility is on the right hand side. So for example, search for a lendable, it obviously interacting with a lendable class. Right, so the next part, similar to user stories, in the UML design, people come up with use case diagram. Basically, you're showing what's the kind of interaction actors who actually use the system have, and what user stories they use. So in this case, you can see there is a member, there is a librarian, and this kind of showing how they interact. So there's the main ones being borrow book, return book. You can obviously think many more like reserve book, write off book, and so on. So the once you kind of know what are the main use cases you need to deal with, what are the different scenarios you need to cope with, and also some kind of, you've divided the responsibilities between classes, then you can come up with the class. Each class would have a name, and you would have basically a number of attributes which determine the state of that object. For example, if there are 500 different book objects, each book object will have a distinct ID, right? As well as maybe other things like title, author. These may not be unique, but ID should be unique to be able to uniquely identify a particular book copy. Similarly, a member would have an ID. So you notice I've forgotten to put ID. A book would also have an ID. A member would have a name, maximum number of books, let's say. Now you notice here, this is a design done by one particular group, and it may not be the best or the most effective way of doing it. And this is what's going to happen with you as part of your design. You will find there isn't a single way to come up with a valid design. So as you can see, the main thing, the library class, or rather one of the things that we have assigned to is a borrow book, return book, get book, and so on. So borrow book means somebody passes the ID of the member as well as ID of the uh, book that he wants to borrow. Based on that, it's going to interact with the particular book object associated with the book ID and the particular member object. So as you can see, there is an association between the library class and the book and member classes. So when your library object is associated with one or more book objects, we show it by using star, right? So it's indicating a multiplicity, and star indicate there could be one or more. And similarly, for you would expect a library to have many member objects. And as I said, the methods that might be part of that object to get things done would be like get current number of books, get maximum number of books, add 1 to the number of books you borrowed, and so on. So if you were to look at this particular borrow or the borrow book method, in order to do that borrow book, it has to interact with a number of other objects. So this is the interaction itself can be captured by either using a collaboration diagram or a sequence diagram. So in this case, we have used a sequence diagram. The good thing with a sequence diagram is it shows the order in which the methods are called. As you can see, in order to carry out this borrow book, this library object, which is the main or the controller object, has to interact with a book and the member object. It has to check whether the book is available. It has to check that the member has not already borrowed the maximum number of books. So the first thing it does is being passed the string IDs, it does not really know which object to interact. Remember, there could be hundreds of book objects and hundreds of member objects. So the first thing it does is, uh, assuming that member ID is unique, it gets a reference to the particular member object. And that is member object is referred to by M. Then the next thing it does is, now having got a handle to that member object, it's now calling the get max. So you are querying what's the maximum number of books you are allowed to borrow. The second thing is you're doing is you're querying the same member object for which you got a handle. How many uh, books have you already borrowed? Say, for example, maximum number of books you're allowed to borrow is 3, and you have already borrowed 3 books, then you shouldn't be allowed to borrow any more books. So here you can see you are calling the get book a reference to, you're getting a reference to the book object, and you are actually calling the borrow method on the book object. Now you might be wondering, why is this borrow method is then calling another method on the member object? The reason is, whenever you borrow a book, since we are asked to keep track of how many books a member has borrowed, it's just calling the add count to add 1 to the number of books borrowed. Now, as I said before, this is by no means the best design or the only design, right? This is just one team has designed their interaction in this way. And also notice that when you call a method, you can also pass arguments. In this case, when you call the borrow method on the book object, you are actually passing a reference to the member object. Using this reference, this method then is able to call the add count on that member object to which is passed as an argument. So once you have come up with a class diagram, you think of the main scenarios, for example, borrow book, return book, reserve book, add book, write off book, and you think of how the different classes, the objects belonging to different classes would interact to get the job done, right? So it gives you a good idea what interaction takes place. And as I said before, if you think about how different objects interact, what methods should be used, what arguments should be passed, and what values should be returned by a method, obviously it's going to make it much easier when you want to integrate all your different classes together. So one of the things that you would have learned in your first year is how to do things using an array, for example. And what you will find is when you go out to work, there are existing classes which makes things much easier to model and to design, right? You try to want to model things as closely as possible to the real world. And as such, there are classes like ArrayList, HashMap, and these, for example, ArrayList is pretty much the same functionality as an array, but the good thing is you can delete in the middle of an array without having to do too much additional work. Exceptions, I'm sure most of you would have used, and basically exception, when something goes wrong, you can basically inform the calling method what went wrong so that they can then take corresponding action, right? Focus on the model aspects. So when you start, do not worry too much about the GUI. For example, if you're doing the chess game, don't worry too much about how the GUI will look like. Focus on what how you can model the board object, how you can have the different pieces, how the pieces can interact, take over another piece. So, and try and come up with a logic to capture that first before worrying about. So also, if you use the model view controller architecture, the idea is to try and separate the user interface or the visualization part from the modeling part. So that way you are free to change a different type of interface. Say you could go from a console mode to using Java FX, or console mode to using Java swing classes, or indeed some other kind of user interface framework. So also remember that for individual user stories, typically you may need to come up with more than one test case or JUnit test case, right? So sometimes you may have to come up with about 10 different cases to test the different scenarios and whether your system can cope with that. So I think this ends the slides part. Now I will get into JUnit.